good morning. As this week's Get Wardle Reading podcast, I'm going to be reading the first section of Unlocking the Universe, which is one of a series of novels called George's Secret Key to the Universe. These are written by Lucy and her dad Stephen Hawking. They're fabulous books. They'd be incredibly useful if you're studying P7 in triple science, or if you've got a real interest in the universe and space science. Okay, so chapter 1, the creation of the universe. There are many different stories about how the world started off. For example, according to the Bushongo people of Central Africa, in the beginning there was only darkness, water and the great god Bumba. One day Bumba, in pain from a stomachache, vomited up the sun. The sun dried up some of the water, leaving land. Still in pain, Bumba vomited up the moon, the stars, and then some animals, the leopard, the crocodile, the turtle, and finally man. Other peoples have other stories. They were early attempts to answer the big questions. Why are we here? Where did we come from? The first scientific evidence to answer these questions was discovered about a century ago. It was found that other galaxies are moving away from us. The universe is expanding. Galaxies are getting further apart. This means that galaxies were closer together in the past. Nearly 14 billion years ago, the universe would have been in a very hot and dense state. The moment it started to move apart is called the Big Bang. The universe started off with a Big Bang, expanding faster and faster. This is called inflation, which also describes the way in which prices in the shops can go up and up. Inflation in the early universe was much more rapid than inflation in prices. We think inflation is high if prices double in a year, but the universe doubled in size many times in a tiny fraction of a second. Inflation made the universe very large and very smooth and flat, but it wasn't completely smooth. There were tiny variations in the universe from place to place. These variations caused minute differences in the temperature of the early universe, which we can see in what is known as the cosmic microwave background. The variations mean that some regions will be expanding slightly slower. The slower regions will eventually stop expanding and collapse to form galaxies and stars. We owe our existence to these variations. If the early universe had been completely smooth, there would be no galaxies or stars, and so life couldn't have developed. The Big Bang. The Big Bang is a theory, an idea or a group of ideas about how the universe began. Scientists look for evidence to show that their ideas are correct. Most scientists accept the Big Bang theory. A voyage across the universe. Before setting out, we must understand what we mean by the terms voyage and universe. The word universe literally means everything that exists. However, the history of astronomy might be regarded as a sequence of steps, and at each step the universe has appeared to get bigger. So what we mean by everything has changed over time. Nowadays, most cosmologists accept the Big Bang theory, according to which the universe started in a state of great compression about 14 billion years ago. This means that the furthest we can see is the distance that light has travelled since the Big Bang. This defines the size of the observable universe. So what is meant by a voyage? First, we must distinguish between peering across the universe and travelling across it. Peering is what astronomers do, and as we will see, involves looking back in time. Travelling is what astronauts do, and involves crossing space. Travelling can also involve another kind of voyage, for as we travel from the Earth to the edge of the observable universe, we are essentially retracing the history of human thought about the scale of the universe. We will now discuss these three journeys in turn. The voyage back through time. The information astronomers receive comes from electromagnetic waves that travel at the speed of light, 300,000 kilometres or 186,000 miles per second. This is very fast, but it is finite, and astronomers often measure distance by the equivalent light travel time. Light takes several minutes to reach us from the Sun, for instance, but years from the nearest star, millions of years from the nearest big galaxy, Andromeda, and many billions of years from the most distant galaxies. This means that as one peers across greater distances, one is also looking further in the past. For example, if we observe a galaxy 10 million light years away, we are seeing it as it was 10 million years ago. A voyage across the universe in this sense is therefore not only a journey through space, it is also a journey back through time, right back to the Big Bang itself. We cannot actually observe all the way back to the Big Bang. The early universe was so hot that it formed a fog of particles that we cannot see through. As the universe expanded, it cooled, and about 380,000 years after the Big Bang, the fog lifted. However, we can still use our theories to speculate about what the universe was like before then. Since the density and temperature increase as we go back in time, our speculation depends on our theories in an area called high energy physics. But we now have a fairly complete picture of the history of the universe. One might expect that our voyage back through time would end at the Big Bang. However, scientists are now trying to understand the physics of creation itself, and any mechanism that can produce our universe could in principle generate others. For example, some people believe the universe undergoes cycles of expansion and collapse, giving us universes strung out in time. Others think that our universe is just one of many bubbles spread out in space. These are variants of what is called the multiverse proposal. The voyage across space. Travelling across the universe physically is much more challenging because of the time it would take. The physicist Albert Einstein proposed two important theories about space and time. In his special theory of relativity, he suggests that no spaceship could travel further or faster than the speed of light. This means it would take at least 100,000 years to cross the galaxy and 10 billion years to cross the universe, at least as judged by someone who stays on Earth. But special relativity also predicts that time flows more slowly for moving observers, so the trip could be much quicker for the astronauts themselves. Indeed, if one could travel at the speed of light, no time at all would pass. No spaceship can travel as fast as light, but one could still gradually accelerate towards this maximum speed. The time experience would then be much shorter than that on Earth. For example, if one were propelled with the acceleration with which bodies fall due to gravity on Earth, a journey across our Milky Way galaxy would only seem to take about 30 years. One could therefore return to Earth in one's own lifetime, although one's friends would have died long ago. If one continued to accelerate beyond the galaxy for a century, one could, in principle, travel to the edge of the currently observable universe. Einstein's other theory, the general theory of relativity, could allow even more exotic possibilities. For example, many astronauts could one day use wormholes or space warp effects, just like in Star Trek and other popular science fiction series, to make these journeys even faster and get home again without losing any friends. But this is all very speculative. The journey through the history of human thought about the universe. To the ancient Greeks, the Earth was the centre of the universe, with the planets, the Sun and the stars being relatively close. This geocentric view, geos meaning Earth, was demolished in the 16th century when Copernicus showed that the Earth and other planets move around the Sun, helios. However, this heliocentric picture did not last very long. Several decades later, Galileo used his newly invented telescope to show that the Milky Way, then known only as a band of light in the sky, consists of numerous stars like the Sun. This discovery not only diminished the status of the Sun, it also vastly increased the size of the known universe. By the 18th century, it was accepted that the Milky Way is a disk of stars, the galaxy, held together by gravity. However, most astronomers still assumed that the Milky Way comprised the whole universe, and this galactocentric view persisted well into the 20th century. Then, in 1924, Edwin Hubble measured the distance to our nearest neighbouring big galaxy, Andromeda, and showed that it had to be well outside the Milky Way. Another shift in the size of the universe. Within a few more years, Hubble had obtained data on several dozen nearby galaxies. His data showed that the galaxies are all moving away from us at a speed that is proportional to their distances from us. The easiest way to picture this is to think of space itself as expanding, just like the surface of an inflating balloon onto which the galaxies are painted. This expansion is known as Hubble's law, and it is now being shown to apply up to distances of tens of billions of light years, a region containing hundreds of billions of galaxies, yet another huge shift of scale. The cosmocentric, cosmos meaning universe, view regards this as the final shift in the size of the universe. This is because the cosmic expansion means that, as one goes back in time, the galaxies get closer together and eventually merge. Before that, the density just continues to increase, back to the Big Bang 14 billion years ago. And we can never see beyond the distance travelled by light since then. However, recently there has been an interesting observational development. Although one expects the expansion of the universe to slow down because of gravity, current observations suggest that it is actually accelerating. Theories to explain this suggest that our observable universe could be a part of a much larger bubble, and this bubble could itself be just one of many bubbles. So what next? So the end point of all three of our journeys, the first back through time, the second across space, and the third retracing the history of human thought, is the same. Those unobservable universes which can only be glimpsed through theories and visited in our minds. I hope you enjoyed that and found it interesting. This is just one of our new science books in the library. The library has recently purchased a whole new set of new books which I hope you'll find interesting. Thanks for listening. Bye now.